The question starts off with an easy part A to identify the state of the substance using the heating curve. So from A, B is solid, and from B to C is a mixture of solid and liquid during melting, and finally at C, D is a liquid state. Why is there no change in temperature for melting? Um, That is because it's during a change of state. And during a change of state, the energy given by the fire is stored as potential energy and is used to weaken the bonds between the particles so as to pull them further apart. That's why during melting, usually the volume occupied by the liquid is much bigger than the volume occupied by the solid. Other words, during melting, there will be an expansion. In part C, we are to calculate out what is the specific capacity of the substance in the solid state. So the answer is 750 joules per kilogram per Kelvin. We will be using these two equations. And first up, because we see a power value over here, so let's use the power equation. From A to B, it takes place across 3 minutes. We need 3 minutes where the heater is working to heat up the object in the solid state. So convert the 3 minutes to seconds, and using the power equation, you can calculate out what is the amount of energy supplied to the material. Now, this amount of energy is then all given to the material to heat it up. So use the specific heat capacity equation, plug in the same value of Q, and you can then get the answer for specific heat capacity. In C part 2, it's a very similar question to part 1 just now. Again, using the heating curve, calculate out the specific latent heat of the fusion. So the answer is 90,000 joules per kilogram needed to melt the object. So same thing, we use the two equations over here. Find out the amount of energy that is applied to melt the object from B to C. So B to C takes place across 6 minutes, and converting it to seconds using the power equation, you can get the amount of energy that is supplied, that is needed to melt the object. Plug this into the specific latent heat equation, and note that the latent heat value is always just the energy needed to melt the object. So with that, you can then calculate out the answer. Okay, in this question, when you are asked to compare the specific capacities using a heating curve, you can use the shortcut where the steeper the gradient will imply a lower specific heat capacity value. I have taught you all how to derive this every time, so we can ask ourselves, is it easy to heat up the object? If it's easy to heat up the object, it means that the specific heat capacity value is very small. When the specific capacity value is very small, it means that you only need a very little amount of energy for you to heat it up. So it's very easy to heat up and raise its temperature. So what does it mean when it's easy to heat up? It means you don't need a lot of energy, which means you need lesser time. You need lesser time for it to increase its temperature. So over here, if you take a look, notice that in 2 minutes, in these 2 minutes, for a solid, um, 2 minutes of heating will raise its temperature by 40 degrees Celsius. Whereas for the liquid, in the same 2 minutes over here, the temperature increase is only 20 degrees Celsius. So it's actually easier to heat up and raise the temperature of the solid compared to the liquid. That is why the specific heat capacity value of the solid is actually lesser than that of the liquid.